All right. So because A starts off at the closest point to the table, at 0, you're going to have the minimum. So we're going to draw our vertical axis over there. And then is this going to be our horizontal axis? Like, is the point A ever going to be on the table, touch the table? No. So we'll draw our horizontal axis kind of below somewhere. Doesn't have to be drawn to scale, obviously. Now, yesterday, I think I labeled these X and Y. We're not going to do that anymore. That was a mistake. We're going to label the horizontal T, and I'm just going to go ahead and put seconds. And we're going to label the vertical D in this case. It tells you it's called D. And that is going to be measured in inches. All right, so we said that the period is 0.25, 1/4, because we do 4 rotations in 1 second. And so a full cycle of this graph is going to be from minimum to minimum. And so from 0 to this minimum, that should be 0.25. Does that make sense? Okay. Now we can find lots of values here. We can find all the maximum and all the middle and all the minimum if we wanted to, but we really only have to do F, G, J, K, and P, and that's all I'm going to do. Well, there'll be one more I'll probably do. All right, so what I'm going to do now to find F is find basically halfway between 0 and 0.25. It's possible. You know that off the top of your head, and that's great. If you don't, it's okay. This is totally doable. So to find halfway, you add the 2 points together, and then you divide by 2. So technically, we're adding 0 and that, so it's just going to be 0.25. And then I'm going to divide that by 2. Now, it's possible it's been a long time since you've divided decimals. I don't know. But when what's underneath is a decimal, all you have to do is just bring that decimal point up. And you can put a 0 in the front if you want to. It's not totally necessary. And then you just start dividing. 2 goes into 2 one time, and then multiply, and then subtract, and then bring down. And then 2 goes into 5 2 times. Multiply, subtract. If you don't get a remainder of 0, what are we going to do? I know it's been a while. You're going to bring down another 0. So as long as you're after a decimal point, you can just keep bringing zeros down, and then it goes evenly, and we're good. So that halfway point is 0.125. Now, some people in my last class just they knew what it was before I even started doing this problem. And if you're like that, it's great. You don't have to show your work, but don't use a calculator. Okay, and then G is going to be halfway between F and J. And so we're going to have to do the whole thing this time. We're going to need to add these 2 together, and then we're going to divide by 2. So when you're adding, I know it feels weird I'm telling you all these things, but when you're adding, you're going to line up the decimal points. And then don't forget, that is not the answer. Now you're going to take it and you're going to divide by 2. I didn't give myself enough room. For those of you that weren't here when I started this problem, if you like fractions better than decimals, if you wanted to have the period be 1/4, you can. And then you're still taking half. You're adding and taking half. So those answers are always correct answers. Okay, so I am going to find another point. All right, so I'm going to find a x value or a t value that I don't really need. But another period is that. That's one cycle. And so it's going to do that in a quarter of a second or 0.25 seconds. So what should this be right here? 0.50 or 1/2 or however you want to write it. I don't need that, but I need it for me because I like to do the halfway points. All right, so P is going to be halfway between 0.25 and 0.5. So I'm going to add that. You guys are going to do this actually. Add those together and divide by 2. And I can come around and just double check yours if you want me to. And then after you're done finding the T value for P, I want you to use it and 0.25 and find another halfway point, please. All right, just so you guys, I saw a lot of people had this right, but just so you don't waste too much time, at P, that should be 0.375. And then you need to find one more. All right, so for K, that should be at 0.3125. It's almost too small to write the whole decimal in it. Now we don't want to round these. We want to give exact decimals. All right, so now that we figured out the t-axis, let's figure out the d-axis. So what is the closest distance that point A is ever going to be from the table? I think you guys labeled it. What do you think? The closest? 15, right? 15 inches. That's going to be here. All right. What about the middle? Like if A was either here or here, what would that be? 45. So it's still going to be this 15 that the whole thing is away. And then plus another 30. That's going to be 45. All right. And then what if point A is up here? We're going to add another 30 to what we just had. And so that's going to be 75. All right. So then now we have all the things we need to be able to give the ordered pairs for all our points. Now, sometimes these problems don't take that long. I don't know the type that they're going to put on the AP exam, but sometimes these are just decimals and you can just figure it out super fast. And then sometimes you're going to have to do a bunch of division. All right, so any questions on part A? That's the hardest part of this one. Well, until we learn another thing and they add the next part. But for A and B, that's definitely the most tedious. All right, so for B, we're going back to this graph from part A, and T1 is going to be F, and T2 is going to be G. So we're talking about this purple range right here. So we're on part I, we're going to decide which is true about the graph of D. So to decide if D is positive or negative, we're deciding if it's above the t-axis or if it's below the t-axis. So what do y'all think? It's definitely above, so it's positive. And then to decide if D is increasing or decreasing, we're just basically looking to see if in that section the graph is rising or falling. So what do you think? Falling, so this is going to be decreasing. Positive and decreasing. And then for part 2, we're going to describe how the rate of change of D is changing. So what are we looking at when we're deciding how the rate of change is changing? Concavity, very good. So how would you describe that little section? Concave up or concave down? Concave down. So would the rate of change of D be increasing or decreasing? Decreasing. So we're going to quote the problem. We're going to say that the rate of change of D is, and you guys just said decreasing. And I'm going to keep quoting over the interval T1 to T2 because, and doesn't it tell you to tell why, but we're going to go ahead and tell why. The reason is because the graph of D is concave down on that interval. I wouldn't just say the graph of D is concave down because sometimes the graph of D is concave up. So be specific about where the graph is concave down. And it might not matter, but it might. All right, so what questions do you guys have on A? Okay, so I'm going to have you guys do B on your own. I'm going to be walking around. It is for a 10-point grade, but before you turn it in, I just kind of want to spot check it a little bit, and then I'll give you another one that you're going to do for a stamp.